Hey everybody, this is Garrett with Earth and Time, and I can bet you know where I'm taking you today. We're going to check out Bryce Canyon National Park, check out how the amazing scenery was developed, talk about the geology behind it, and check out some of the most popular spots along the Bryce Canyon, what they call the amphitheater. So with that being said, let's get to it. So where are we at right now? We are sitting right here in southwestern Utah. So this is the United States. Here's the outline of Utah, and we're kind of here in the southwestern portion of Utah. And that's where Bryce Canyon National Park resides. So they have a great geologic exhibit here. So let's go ahead and walk through that geologic story. And what they've done is they've broken it up really and color coded it. Now they talk about time. So from 525 million to 70 million years ago, there was deposition here in the Colorado Plateau area. Before the Colorado Plateau was the Colorado Plateau. That didn't happen until much later. But what they've done is they actually talk about the different rock units here, show some examples of those, but they really call them by color, and we'll see that like vermilion and red and gray, and we'll take a look at that in the cross-sectional view. But basically what happened in this area is you had a lot of deposition of both terrestrial or land-based type systems, and this was during the time of the dinosaurs. Coming from here all the way up here was all during the time of the dinosaurs, and something drastic started occurring about 70 million years ago. You had what was known as a Laramine orogeny, and you had the uplift of the Colorado Plateau as a whole, and that occurred from 70 to 45 million years ago. And we can see where we saw those layers before coming from these deeper ones, and we see uplift here, and kind of the vermilion, the red, kind of going lighter gray to darker gray, they all started getting bowed and pushed up, which meant you ended up with erosion. Now with that erosion and with that pushing up, that means we're going to have some low-lying areas, and within those low-lying areas, we had deposition of the Claron Formation at about 50 million years ago. So you can think of this as a giant freshwater lake, something like Lake Superior today or one of the Great Lakes, but it occurred here in central Utah. And that is actually the deposits that make up Bryce Canyon National Park. But that's just the first part of the story, because we had to have it deposited first. Now, we come to about 6 million years ago, and there's a lot of erosion taking place, which has now exposed things like the Grand Canyon. There's some of these gray units. We can come over here, and erosion continues to chip away at all the stratigraphy here that was once flat, has been bowed up. It's still pretty flat here on the top of the Colorado Plateau, but what's most important for us here at Bryce Canyon National Park is we can see where the Claron Formation sits, is the youngest unit on top of the plateau here for the most part. I will say there are some volcanic flows up here that are much younger, but as part of the overall story here, we have the Claron Formation, which makes up Bryce Canyon National Park, which is a series of lacustrine or lake deposits. How do they know it's a lacustrine or lake environment in the Claron, this material that makes up Bryce Canyon National Park? Well, it's because they found some freshwater snails. They can also look at other indicators, like they can see river deposits that cut through some of these features, and they can look for different kinds of burrows or trace fossils, which give them a hint that we were in a lake environment as opposed to something like an ocean environment. So now that the Claron's been deposited and it's now part of the Colorado Plateau, the story of the Hoodoos here, or the fantastic features that you see in Bryce, are really a story of erosion. And that erosion starts kicking off about 15 million years ago here. But what happens here is you have a series of faults coming into this area. So the Basin Range has been initiated, and that's off to the west of us. Take a look at this map of the United States to see where we're at. So here's where we're at, Bryce. So Basin Range is kicking off and creating all the hills and ranges, or basins and ranges over here. And some of those start propagating into the Colorado Plateau, the western portion. And one of those, known as a Ponderosa Fault. And that Ponderosa Fault is a normal fault, and it drops down the layers. The layers that you see here are the pink cliffs representing the Claron. Here are the gray cliffs that represent the ancient ocean during the time of the dinosaurs. The white cliffs and vermilion cliffs, all times represent times during the dinosaurs. This being the latest time and earlier. But what's important is this fault is what's known as a normal fault, which means we're going to drop down one side relative to the other. As I pull the lever, we can see the one side drop down. And this is a normal fault. Now, when you start dropping down one side of the stratigraphy relative to the other, something starts occurring on the side that's left up high. And that is, you've set it up to be higher up and be affected more by erosion, which is exactly what we see. And so here's a nice cross section. So you can think of like if you cut a cake in half, you can see the layers. Geologists call these cross sections, and we use this to understand what's happening underneath our feet or deeper into the earth. And this is a nice example of one of those cross sections through here. Here's the Pink Cliffs or the Claron Formation, and you can see that it's exposed an area high relative to the other side here across the Ponderosa Fault, which means it's going to be more prone to erosion. And over millions of years, lakes and rivers and freeze-thaw action start to chip away at this area, eventually ending up with what we have today with the Bryce Amphitheater, which interesting enough is actually on the, as you can see, the down-thrown side, or what we call the hanging wall side of the fault. We can see off in the distance, once we go outside, I think we'll be able to see the Ponderosa Plateau. But here we are at Bryce, and we're somewhere right now at the Visitor Center, somewhere right in this area. And here's more about Bryce Canyon faulting and erosion. So the fault that comes through here is the Ponderosa Fault, and it's a normal fault related to extension into this area from the Basin Range. You'll see one side goes up, one side goes down. And erosion through time develops those amphitheaters, and we have today Bryce Canyon National Park. And it's most famous for the hoodoos that are developed, which are due to a combination of the rock types that were deposited, which include dolomite and limestone, both very resistive rocks, and then sandstones and mudstones and siltstones, which can be less resistive. And through freeze-thaw action, basically water getting between cracks like we'd see here, and as water freezes, it expands, so it'll actually crack and slowly split apart the rocks, and then water can come through rain, or wind can come through and start moving that debris out. So you end up getting these hoodoos that have these nice dolomite or limestone caps on them, and then all the softer material erodes out, and you create these amazing pillars known as hoodoos. Here's a nice video on how hoodoos were formed, so I'm just going to let this play for a minute. And I like that they're fast forwarding through time, so you can see erosion taking place, and you notice there's freeze-thaw action, creates this ice wedge in there, starts breaking them apart. And this is what we have today in Bryce Canyon. And here's a nice example talking about some of that. So you have these dolostones or dolomites on top. You have limestones helping to set these up. So those are the more resistive or blocky units you'll see. And the mudstones are going to be these less resistive units that you see inside where you see the recesses. There's also siltstones in there as well. Right, so here's a nice diorama or model showing Bryce Canyon. So we're here at the Visitor Center right now. We're going to work our way down and take a look at a number of these different points so we can look at the hoodoos and talk about the geology of them as we work our way around the park. All right, from the Visitor Center, let's go ahead and take a look at some of the overlooks here at Bryce Canyon and see what these hoodoos look like in person. We've learned about the geology of them. We've taken a look at them inside, but let's actually go out to some of these points and see them in real life. Pretty exciting. All right, welcome to Rainbow Point. We're about 18 miles from the Visitor Center, and I'm starting at the very end of the park, so this is the very last stop, and as far as you can drive in the park. As reference, we're here on the southernmost tip of the park, and we started, if I come up this direction, up here at the Visitor Center. And this is the view from there, where you can start seeing some of those hoodoos out there that we were talking about at the Visitor Center, where you can see how erosion through time has started to form these amazing landscapes that we can see here. Now, if I go on the other side of Rainbow Point, again, we can see the amazing hoodoos that make up Bryce Canyon in this amphitheater. And it's called an amphitheater because we can see the semicircular nature of this whole section due to erosion. So there's a series of rivers and streams that come down that are moving all this material away off in the distance, eventually working its way all the way down towards, I believe, the Grand Canyon. The other thing I want to point out here is the other plateau you can see over there is the upthrown side of the Ponderosa Plateau. So the Ponderosa Fault that dropped this side down relative to us, if you remember from the visitor center, seeing those faults, occurs somewhere between us and where you can see the rainstorms out there and the other plateau in the distance. And from this vantage point, you can really see the amphitheater nature and why they call this the Bryce Canyon Amphitheater. And you can see all the erosion happening. Now, the gray unit that was part of the old Mesozoic ocean that was here during the time of the dinosaurs are all the gray material you can see down below. And it's part of the Cretaceous. As I come in here and I zoom in on some of these hoodoos, you can see the more resistive units on top. So those more resistive units, or the square blockier units that are usually lighter color, are going to be either dolomite or limestone. And your less resistive units that are in between are going to be more of your mudstones and siltstones. And you can see some really nice examples of the mudstones here and siltstones here as the slope formers just below that white cliff, which is probably either a limestone or dolostone. I'm not sure unless I got up to it and took a look. The various colors have to do with also what kinds of minerals are deposited with them. So the white here I think are the dolostones and limestones. You can see the more red there are going to be more iron-rich sediments that were deposited in the lake or later water that came through that helped create these pinks, which are I believe manganese and iron mostly. But it's a spectacular view from this vantage point. If you need some reference about the geology here again, they have signs everywhere, which I love. It's really, this place is here because of the geology, and it talks about 50 million years ago again that you had that freshwater lake that was here, and then the Ponderosa Plateau in which we are standing rose near sea level to over 8,000 feet to its east. And what's known as the Pryor River was what helped form and carve a lot of what we see. Oh, here's a bit about the colors I was just talking about. So pure limestone is white, but here iron deposits have oxidized or rusted, producing the yellows, oranges, reds, and browns. Oxidized manganese creates the pale blue and purple hues. Changing weather and light also affect the canyon's colors. Oh, neat. So manganese and iron. Now that we visited the viewpoint here, we're going to work our way back and make some stops and make some observations as we work our way back towards the north. I eventually want to get up here to Bryce Point and pretty a view with all of you so we can look at some of those and some of the sunset points. Those are some of the most classic looking hoodoo areas that people are going to be most familiar with. Although I'm a geologist and I'm here because I'm so fascinated by the rocks, I do want to point out all the lush vegetation up here that you can see on top of the plateau as well. There's beautiful pine trees. There's actually bristlecone pines here, and there is a bristlecone pine trail. Bristlecone pines being the oldest living organisms in the world, and some of those are here, actually not too far from where I'm staying now. It's a little bit of a hike and something I don't have time for, but if you come here, please take the time to go check out the bristlecone pines and enjoy all that nature has to offer up here. And of course, gotta enjoy the rocks. So I moved north along the road, about 2 or 3 miles, and we're still in the same amphitheater we were looking at from that Rainbow Point. This does give you a slightly different view. Not as many hoodoos here, but you can really see off in the distance, including the plateau out there. And we know there's that big fault that's dropping down and coming towards us between those two. So I've gone outside of Bryce National Park now to show you the normal fault zone I was talking about before, and you can see it right here. So you have the Claron Formation on the left-hand side where you can see that orangish pink color, and on the right-hand side you can see that grayish buff color, and that is the Cretaceous, and I believe it's a combination of the Tropic Sandstone and potentially the Straight Cliffs Formation. But what you're actually seeing there is that Ponderosa Fault, and it's dipping away from us. So it's a really nice view just outside the park here going towards the town of Tropic if anybody wants to go see that fault zone. You can see some interesting patterns within the rocks here, and you can see some of the softer material that's eroding and then some of the more or less erosive material on top, starting to create some of these hoodoos. All right, so we moved our way from down at Rainbow Point. We stopped kind of in this Black Birch Canyon area somewhere in here, and now we're here at what's known as Ponderosa Canyon. And one of the reasons I wanted to stop here is we actually get pretty close to what is known is the white unit here of the Claron Formation. They have different units, so they have a white unit, an upper red, a middle red, and you can see why they call those units different names. And that allows the geologists and stratigraphers to keep track of observations as they work around and move through these different plateaus, so you can basically connect the dots on the map. And so that helps them do that. Here at Agua Canyon, you can see some classic hoodoos, like the one sitting in front of me. As I move over, you'll see another one over there. So these are what we expect to see when we think of hoodoos, and a lot of times what people think of when they think of the Western United States, they actually think of this kind of topography. Now, one of the interesting things we can see, if I zoom in right in there, is you can actually see a crack starting to form. So this is where the water would get in between, and in the winter, as the ice freezes, it expands, and then when it warms up, it unfreezes, becomes water, drips down and starts moving material, and you can see actual in process freeze thaw action there that's going to eventually create probably another hoodoo. And we've talked about during the course of this video the more resistive units, which you can see up here. So this is going to be a limestone or dolomite on top, which is more resistant to erosion, and if you look down towards the base where it gets more that buff colored to red color, that's more of the mudstones and siltstones, which are more erosive. And so you end up with this cap rock of limestone and then the more erosive base, which gives us those classic hoodoo shapes. And as the early pioneers call them, they called them fairyland here, or fairy chimneys. And you can see why when people first saw those, they had all kinds of ideas of what they could be. All right, so our next stop is actually at Natural Bridge, and this is a fascinating place where you can really see the story of erosion taking place. And what they've done, they actually have done a little bit of a time lapse here showing here's what this area looked like coming out. Here's this little pillar or shelf coming out into the canyon, and through time, both freeze thaw, you've heard me talk about that a lot, along with wind and erosion, slowly ate away the less consolidated material underneath, eventually leaving what we can see right there. Check that out. It's a natural bridge. So we have the more resistive limestone on top, and that continues down quite a ways, and you can see through the transition where it becomes the less resistive mudstone down there. Pretty cool geologic feature, natural feature to see out here, and pretty rare. And there's still a hoodoo over there as well, and it's kind of a funky looking hoodoo. So I've stopped at Fairview Point, and this is a point that's known for, I guess, seeing condors in the area. And actually, as I pan up, there's a condor right there, I think. That's pretty cool. And we just came from seeing one natural bridge. Here's another right down here. And you can really see the resistive limestone unit or dolomite unit on top, and then where all the less resistive material was eroded underneath, leaving that bridge. And if I look parallel to me, we can see we're in this white cliff member again, where this is all that limestone coming through here. It's amazing to me to look across here and see all this material and realize how big this lake must have been to deposit this, and how long lived it must have been, because there's a lot of material here. Pretty fascinating. It's hundreds and hundreds of feet of lake deposits. Now we're about halfway back towards the entrance. We've dropped an elevation, and we can start seeing more of these hoodoos here, and instead where we saw them kind of more of the buff colored, red color ones, we're seeing a little bit more of these kind of classic white looking hoodoos that are all made up of, you can kind of see the limestone is that white color throughout this area. This is a nice little valley coming through, and you can get an idea about and see where the fractures are occurring, where these hoodoos are starting to form. Okay, we've moved really on the north part of the park now, and we are sitting right here. I'm going to walk us out here to Bryce Point, which is one of the famous viewpoints out here. A lot of folks, if you come here, they come down here and they'll do this Peekaboo Loop Trail. It's a lot of fun. Another trail I really like to do is from Sunset Point, and it's the Navajo Loop Trail, and you come around to Queen's Garden. So that's one of my other favorite trails. I'm not going to have time to do them today, but those are both good ones if you all come here sometime. So at Bryce Point, you can start seeing a number of arches being developed due to erosion and some more bridges. You can see we're in this white unit of the Claron, and you can see all the different hoodoos forming. We're now really getting into the edge of the main amphitheater of Bryce Canyon National Park. And here are by far some of the best views of hoodoos in all the world. And I'm going to work my way to Bryce Point there and point out some of the very unique features down here and talk a little bit more about the geology. As I walk out to Bryce Point, I will say if you're going to come somewhere and only have a little bit of time, this is the one to come take a look at. If I look down there, I don't know if you all can see, there's actually people down there. So there's a number of trails that go down into the amphitheater from this point and from Sunset Point. And if you have time to do those, like we saw on the map, it's really worth going down and doing them. Now, I recommend, it's summertime now, make sure you have plenty of water, doing them earlier in the day because it does get quite hot down there. So you can see another one of the arches over there that have been developed, or bridges. And you can see a whole series of them starting to get developed in the limestone cliffs there. Now, right below me is a nice example of an old river deposit, and you can actually see the gravels and what we call cross bedding. And so I know these were old stream deposits that came in and are probably one of the latest things to occur here. In fact, we can see we had a bunch of lake deposits, and then eventually a river comes through here, and this is the evidence we see of that river here. So the lake probably filled in for the most part, and then as water continued to come through this area, you had rivers scouring down into these deposits. Now, this is still, I believe, part of the Claron Formation as well. And look at that. This is often the picture you see for Bryce Canyon National Park. And again, if we talk about the geology, we can start at the bottom. We can see kind of this lower red member down there. All those red rocks down there are those iron stained rocks. The white are the limestones and dolomites that you can see to gray that make the caps of a lot of those features. And as we continue on up from there, looking up the amphitheater, we can see more kind of a red zone there. And this is where you can start seeing some of those pinks and other colors. And you can work your way all the way up into some more of the white limestone. But it's amazing seeing all the different colors and seeing this amazing landscape. Really looks otherworldly. So there are other vantage points you can go to. Sunset Point is over on those hills over there, and Inspiration Point, and there's some hikes, and you'll see there's trails down there, and those hikes start from that other side. But I want to give you a nice pan through this area and to look again at all these hoodoos down here, and we can see where the old rivers came through that helped dissect and create the amphitheater that we see. Welcome to Sunset Point, and we can see Thor's hammer right there. This is probably the most popular hike in the park, and you can actually see individuals hiking down there. And this is a great spot to actually see some of the geology up close. And if you don't get a chance to go down, it's definitely worth stopping here, walking along the rim, and taking a look at all the amazing hoodoos within this amphitheater. Here's looking down at the trail you can do for Wall Street, I believe is what it's called, and it comes down through, you'll go past Thor's hammer right here and down through some narrows in there, what they call Wall Street, because you go between these big fins of the Claron Formation, and you're right down in the amphitheater. When you're down there, you really get an idea for scale, and you can see the people, and you get an idea just how thick these lake deposits are and how long lived this lake must have been to deposit that much material across this area. And the fact that it had this variation of limestones when the weather must have been perfect or the conditions were just right to more muddy deposits. So I can't imagine a better place to end the video than here at Bryce Point. Thank you all for joining me today to learn about the geology and the fascinating scenery that's here at Bryce Canyon National Park. I hope you all learned something. I know I sure did. I hope you all get a chance to come here and visit this fantastic place. If you enjoyed this video, you all know what to do by this time. So this is Garrett with Earth and Time. Thanks for joining me today, and take care.